quick update on this latest batch of LiBCM PCBs. I have 42 of them here that are fully manufactured at this point, and I am just starting to test them. So I've tested 2 of them now, and I rewrote the test code and basically combined 2 test fixtures, so that one and this one, into just one test fixture, which is just this one. And that was just with some firmware changes, how we test stuff. And so that's actually going to save me several minutes per board, so that's nice for the verification. So I just wanted to walk through the process, and I'll probably also talk through what I've been up to these last couple weeks, although not everything. Got a couple things I'm still working on that I'm not quite ready to talk about yet, but all good news. So yeah, just going to walk through the process with this random circuit board here. First thing we do is we mount up to this holder, and then we're going to go in and plug the ribbon cables. This test is very similar to the old test that I did. I've again just changed a bunch of the firmware so that I no longer need 2 different hardware test fixtures, so I don't have to plug 2 different tests in. I just only have to do it once now. I also removed the thermal imager. I used to manually image these to make sure that all of the discharge resistors were working, so I would turn every other one on and make sure that it was hot on the imager, and then I would turn those off and turn the other ones on and make sure those got hot. It actually took quite a bit of time, and the reason I had to do that is that with my old test fixture, I had some voltage issues. The PFETs I'm using here have a gate turn on of around 2.5 volts, and we weren't getting there before. We were only at about 2 volts, I want to say, if I remember correctly. So some hardware changes, again, saves me quite a bit of time, probably enough time on this batch to film this video and upload it. So the video doesn't cost me any effort, although these videos, as you'll see, don't cost me much effort anyway, because I don't do any editing on them at all. So we're going to plug in our test harness here, and I'll mention that when I first started shipping these, the first batch of maybe the first 10 or so, I actually put each one, every single one, in my car, drove it around, and that was basically how I tested it. So this test fixture saves my back. In addition to a ton of time, it saves my back, so I'm not having to put a pack into and out of the car every single time. Now, I knew that was unsustainable back then, but I just hadn't developed this test fixture. And I initially only had one test fixture, and then I added a second one to cover some test gaps. And now, as of today, I've combined those 2, as I mentioned already, which saves me some time. All about saving time, so I can waste it doing other things, like LiBCM. Okay. So we pretty much have to hook up to every single connector on this board, and goodness, there are quite a few. Lots of things that we are talking to and measuring. These are the temp sensors here. So yeah, where have I been the last few weeks? I had a friend come into town, and we climbed for a good solid week. That was 1 week of it. The week before that, I was dealing with the potentiometer issues, which I feel like I've documented well enough to not need to talk about it. The new replacement ones should be here in mid-December, but we'll see if that actually happens. Alright, so I think that's everything. I used to have a crib sheet. Well, I still do have a crib sheet. I've had to test this, but at this point I basically do it from memory. So we're going to program our device here. And once that finishes, let's see, I don't think that error was real. Never had that one before. Yeah, we've definitely, let's open this up. So yeah, we're flashing our EEPROM. I'm pretty sure we got programmed here. So what I need to do now is turn these 2 power supplies on. One of them is 200 volts and the other one is 2 volts. and that gives us the relevant voltages we need. So we're doing some bit pattern tests here, and now I have to manually make sure that this screen blinks and that LED works and this turns on. It's just much easier than hooking up test stuff to it. So this one passed. So far all 3 have passed. I think the pass rate on this batch is going to be extraordinarily high because with the new reflow profile that I talked about previously, there just aren't a lot of defects on these boards. I didn't keep track, but more than half of these boards were perfect. They required no rework, and then of the remaining half, probably 90% of them had like a lifted pin or a tombstoned part, which is pretty common. That failure rate's a little bit high if you were in industry doing, production. You had great production equipment. I don't really. I'm doing it in my garage. So let's pop this off. We're going to take this all apart now. That's the whole test. So now every time I do that, I don't have the second test at all. I don't have to do anything else. Actually, there is one other thing here. I wouldn't normally forget this except that I'm filming a video. I need to take and copy and paste this test in here. This could be automated out. And yeah, so that's passing here. I've got some various test data to look at here. Yeah, that one's really good. This could, of course, be written into code, but I'm just not sure I'm going to do that because it takes effort, and it only takes me a second to copy and paste it in there. I'd probably never recoup that time. So the only reason that I would want to automate it is if for some reason I were handing this off to someone else and they didn't know what they were looking for. A simple pass or fail is much easier than having to look at data. I've looked at lots of data, specifically for LiBCM here, so I'm just going to eyeball it right now. This is replacing the thermal imaging test, so saves me quite a bit of time doing that. Yeah, most of this test, I mean, you saw that test, it happens in 10 seconds or so. And that's testing pretty much everything on the board. And so that's instead of having to spend an hour plus putting it into the car. I mean, I passed that way long ago, probably 2 years ago is the last time I put units in the car. I used to actually test these with actual batteries, but at this point I don't even do that either. The test is good enough at this point that I don't need to do that. The rationale used to be that I didn't want the user to be the first one plugging in batteries. But at this point we are applying that voltage. In fact, we're applying slightly higher, up to maybe 4.2 volts. You can see 4.195 there. So not worried about the customer being a guinea pig there. Okay, I think that's everything. So yeah, that's it. We pull this off, we stick our past final sticker on like that, and that is actually ready to be built up into whatever it is, Fomoco, whatever. They're all the same, so Fomoco, I've been saying Fomoco, but apparently it's Fomoco, I don't even know. John Miner can hop in here, he's the one that corrected me on that, and gotta trust him there because I'm pretty sure he worked there, or maybe works there. Anyway, the Fomoco, I think that's correct, and the 5 amp hour G3 PCBs are identical. It's just the firmware you're putting on them, and then of course the things you're plugging into it. So that's pretty nice to have the part reusability there. Yeah, so yeah, otherwise what have I been up to? I've been doing a lot of stuff behind the scenes for this project. My recent announcement about Green Tech selling those batteries, that was a little bit of work. I mean, I spent, a year and a half trying to get those modules, and then now Green Tech has them, and the price is good, and I had the opportunity to get them and passed on it because I didn't want to deal with the shipping logistics and the warehousing and all that stuff, and so that's what Green Tech is doing there, and the price is reasonable. So I am working on another battery deal. I've kind of been mentioning that on and off. I'm waiting for it to be complete before I officially say it. So if you know what I'm talking about, that's cool. and if you don't, please don't speculate publicly. I will announce at the appropriate time when that deal, if that deal goes through. So, yeah, otherwise I've been working with some governmental stuff, tax stuff. Again, I mentioned those potentiometers. I had a couple of Insight people come last week and stay for a couple of days, and we went and hiked. It's fall here; it's beautiful. So, rewriting this test fixture. All I'm trying to say is that I've been doing a lot of stuff behind the scenes, but there's not a lot of public output. Basically, maybe I'll say. Now, of course, these 42 PCBs, soldering all of this stuff has been a lot of work, but I've only honestly spent, I don't know, I spent 3 days building the 42 PCBs, and I probably spent another 3 days soldering everything onto them. The hand soldering takes a lot of time. I mean, you're soldering a lot of through-hole parts, of course, verifying and fixing them. This is the real, only like work product, but I think at this point, I think all 42 of these units are already reserved. So they will sell immediately, and I'll probably have to go right into another batch. Yeah, no real point other than just to document this new process. This way I can come back and look at it later if I need a reminder about what connects where or whatever. So this video is for myself and also for whomever is interested or bored enough to watch it. So as always, thanks for watching.